Okay, so question 11. I've already made some annotations on here. Again, video kind of failed a little bit on me, but you've got you're told that the radius of this hemisphere is x, so that's x in this direction. The radius will also be x in that direction, which means if this whole length here is 5x, and that's x, the height of the cone must be 4x. So if you read through the question, it ends up telling you that the volume of this shape is equal to the volume of this shape. So this shape at the top, to find the total volume, we've got the hemisphere bit. Well, if the volume of a sphere is 4 over 3 pi r cubed, if we half that, the volume of the hemisphere is 2 over 3 pi r cubed. Now we know the radius is x, so instead of writing r cubed, I'm going to do x cubed. And you've got to add that to the volume of the cone. Now it's a full cone, so we don't actually need to adapt this formula. So we're adding that to the volume of the cone, which is a third pi r squared. Well, if the radius is x, we'll call that x squared, times by h. Now we actually know the height of the cone in terms of x. It's 4x. It's not 5x, that's from the top of the hemisphere all the way down to there. It's 4x. So I'll put 4x in here. And if I times all of that together, I've got 2/3 pi x cubed plus, so the 4 times by a third gives you 4 over 3. The x times the x squared gives you x cubed, and then you've still got the pi there. Now both of these now are x cubed terms, so I can actually combine these. 2 over 3 pi plus 4 over 3 pi, which gives me 6 over 3 pi x cubed. Now 6 divided by 3 is 2, so that's 2 pi x cubed. That's the volume of this top, what they call the solid, the top solid, the top 3D shape. They tell you that the volume of that is equal to the volume of this. So even before anything else, just making sure you get method marks, we're going to try and find this volume accurately, and we're going to try and find this volume accurately. Now the volume of a cylinder, V, is equal to, you're not given it here, but because it's a prism, you just find the area of the cross section and then times it by how far it's stretched out. So the area of the circle is pi r squared, the radius is 2x, so it's pi 2x squared, and then you're going to times that by how far it's stretched out, which in this case we refer to as h. So the volume is, that becomes 4x squared, because you've got to square the 2 as well, 4x squared pi h. Now, the cylinder has the same volume as the solid. So even before you read anything else through, we're going to have to set these two volumes equal to each other. So I've got 4x squared pi h is equal to 2 pi x cubed. I'm going to immediately divide both sides by pi to get rid of them. And I'm going to immediately divide both sides by 2. So that goes and that becomes a 2. So I'm left with 2x squared h equals x cubed. Well, let's divide both sides by x squared, so that disappears and this just becomes an x. And then if I divide both sides by 2, I get h is equal to x over 2. And if you read the question, find a formula for h in terms of x. So it's h in terms of, remember if you ever see something in terms of, you're making that the subject. So you're making h the subject and it's in terms of x. That's your final answer.